Thanks for having me. How's everybody doing today? Like it was said, feel free to put any questions you have in chat, or if you just want to unmute and ask them, feel free to do that. All right, so we're going to talk about how to tune multi-terabyte databases for optimum performance today. A little bit about me. I am a software and data architect. I've been working with SQL Server since version 6.5 back in, I guess, 97. And I'm currently the president of Jacksonville SQL Server Users Group. And I post articles online every once in a while on Twitter, and also blog at my website right there, which you can check out if you'd like. All right, so to get started, I have some questions for the audience. If you would navigate to this link here, it's meet.ps, tune TBDB, and I will paste this into the chat window. When you successfully navigate there, you should see a screen that kind of looks like this screen that I'm showing you here. And I want to you to click on the poll here if it doesn't automatically pop up, and I want to know what your current role is. In your current position, what is your role? I'm just trying to figure out how many DBAs we have here in the audience. So we'll wait a minute for that, for you all to get over there. And once you click through, we'll be able to see how many of you are DBAs or something else. So wait a minute for that. All right, so I think there's about 13 of us in here, so I'll give it another second to let the last few people take the poll. All right, the URL again is right here. Almost there. We got 9 people who have taken it. Yeah, go ahead. At the bottom of the screen, if you look all the way at the bottom, it's the third icon over. It says polls, and you can go ahead and click that if it doesn't automatically pop up. All right, we're at 10. All right, so it looks right now that about 40% of the attendees are DBAs, another 40% are developers. And then we have a manager or two and the other. For those of you who are other, can you maybe put in the chat window what your current role is? Just so we know. And I'm going to start the second question here. I just want to know, what version of SQL Server are you currently using in production? So what is actively in production? And if you could check all that apply and let me know what you have here. It looks like I'm actually missing one in this list. This is a new interactive polling site that I started using, and I just kind of wanted to see what it would look like here. All right, that's pretty cool. We have about 85% of you using 2019, which is great. Now, who's using 2005 and 2008 R2? Now, you know Microsoft has stopped supporting that, so you need to get those upgraded right away, because those are essentially the dinosaurs of databases right now. All right, anyone else? We've got 7 people who've submitted. If you don't know, that's fine. You don't have to answer. All right, and for our last question before we get started, what SQL Server edition are you currently running in production? Are you using Enterprise or Standard? And you can check all that apply. So it looks like quite a few of you are using both, I would say, it looks like, in production, which is interesting. Because depending on your version, you may or may not be able to use some of the features we talk about. So if you have a multi-terabyte database in Standard Edition, one of my recommendations is to definitely move to Enterprise as soon as possible. All right, awesome. So let's continue on. Hang on. Yeah, sorry, I did forget 2016 in there. I threw this together at the last minute. So yeah, no SQL 2016 option. I will adjust that for later. Looks like we've got a couple using that. So Hugo, I believe, you're using 2008 R2. So just so you're aware, you could actually upgrade your server and keep your compatibility level at 2008 R2, and that database should run the same way. So just so you know, you can do that with the newer versions of SQL Server and have the same database run there without any issues. Interesting. What product is that? Sorry, the question, he said he knows, but it's not supported by the vendor, which is Microsoft. What is that product? I'd be interested in knowing. I don't think I've ever heard that. NAS Vision 2009. I'll have to look into that. I've never heard that before. Well, that's surprising. All right. So I want to talk about some of the problems that I've encountered as a consultant and in my line of work. Some of the companies and clients that I've worked for have come to me and said, hey, we have queries that take minutes to run, hours to finish processing. Our application timeouts had to be extended because the queries wouldn't even return in, say, the 30 seconds or 90 seconds that the application would typically allow. Sometimes the databases are so large that index maintenance can't be finished in a night, let alone even started. One of the clients I recently was working with, they had actually turned maintenance off completely because they couldn't finish it in time. Some of the indexes that they tried to create would take 48 hours to create on one table with billions of records. Full backups in these instances would take 12 hours to complete. Some of these databases were 2, some of these were 4 terabytes, some of these were 5 or 6 terabytes. Would take 12 hours to back up, and that's a really long time for that size of database. The database log in some of these instances were kept in simple mode, even though they probably should have been in full transaction mode, because the transaction log backups couldn't keep up. So there were so many transactions and so much data that they were moving that they had to keep the database in simple mode, which can create a lot of problems if you're trying to do a point-in-time restore when you need it. Another client I encountered had actual nested virtual hard drives. So they actually had a VM host. That VM host had a large hard drive, but instead of directly connecting a SAN drive to the VM directly, they actually created a VHD inside of the host and pointed the VM to that. So essentially they were daisy chaining hard drives, and that was causing a lot of performance issues. So first things first, right? If you've encountered any of these issues, if you're a manager or a company or a developer and you need help or you've seen these issues, first things first, you need to hire a DBA, because a DBA will help get through these problems for you. Preferably, you need to hire one who knows servers and storage, meaning your SANs and how to connect it up if it's on-premise. If it's not, you still need to hire someone who knows storage, right? Because whether you're in the cloud or you are on-premise, you definitely need someone who knows storage and performance. If you are in Standard Edition, move to Enterprise. There are a number of benefits with Enterprise Server that just come out of the box from just migrating there for large databases, including one key component, which is multi-threaded index creation. So that one instance that I was speaking about before, where it took 4 to 8 hours to create one index, they were on Standard Edition, which when you create index, only uses a single thread to create it. So immediately you're handicapped with Standard Edition. All right, so let's talk about the agenda today. First thing we're going to talk about is how do we assess and test the network and the server and database configuration. We're going to talk about how to determine what kind of data you have, because that's important. We're going to kind of talk about some of the queries and the filters that you use to see if there's other ways of querying or maintaining that data, perhaps using partitions. We're going to review and adjust data types and show you how to do that. We're going to talk about data types and data sizes specifically and how that matters with performance. We're going to talk about how to actually move and fix those data types and sizes. And then we're going to talk about how to clean up. So here's a question. Would you rather use a bicycle to race on a road course like this? Or would you rather use a motorcycle like a Ducati to race? Feel free to post in the chat, because I can't hear any of you. I'm guessing all the mute is off, or that everybody's muted. Is there any way we can get the mute to be, everybody to be unmuted so they can manage that themselves, moderator?
Yeah, I'll have to do it individually, but let me go ahead and do that.
Okay. Yeah, if you guys feel free to, once he unmutes everybody, if you guys wanted to mute and unmute yourself, feel free to interact. Or type if you don't feel like talking. But yeah, someone said they're partial to unicycles. Yeah, I don't know how a unicycle would work too well on those curvy courses, but yeah. Ducati definitely, I think, would be the preferred method of travel here. So here's a question. Would you rather use a pickup truck to carry your hay? Or would you rather use a tractor trailer that you can fit a ton more of hay on at one time? Who would rather use a garden hose to put out a fire or to transfer water from one place to another? Or would you rather use something like this? This is actually a reservoir let off in one of the canyons. And I found this picture and I thought this would be perfect. Or how about 4 of them? The reason why I'm showing these pictures is because I want to kind of show you the aspect of your data. Is your data going through a pipe as small as a hose, or is it going through a pipe that's 6 to 9 feet high? So the first thing we need is a better design, bigger pipes, right? So we need to assess and test the current system. We need to look at infrastructure design. We need to look at our data types. We need to look at our logical separation and physical separation. So the first thing we need to do is measure our throughput. So we want to look at SQL Server file I/O per database and see what kind of throughput we're getting. So the way we could do that is we can take a query here and we can look at some of the DMVs inside of SQL Server. And I have this script in there, so if you want to look at it later, you can. But this is kind of what it looks like. So the output here, it shows you all of the database names. It shows you the I/O in gigabytes. And then it does a percentage calculation in the last column to show you which database essentially is transferring the most data. So in this case here, you can see that this first database is transferring 120,103.35 gigs. And this is since SQL Server has started. So since the server was last rebooted, this is how much it's transferred in I/O. And that counts for 65% of the overall throughput in this server. You can also see here that TempDB has done about 50,000 or almost 51,000 gigs, which is almost 30% of the throughput for this server. So these two databases are the biggest ones on this server. And you can see there's plenty of others, but these are the two you would probably want to focus on, or maybe even three, in tuning and making sure that it performs faster. So another thing we want to look at inside of SQL Server is the latency. You want to look at the SQL Server latency per file. So here's another query that looks at the some of the DMVs inside of SQL Server, looks at the virtual file stats, and converts that into essentially a readable format for us to show us the latency for each one of those files. So that query will output all of the actual physical files. This will do your data files, your MDF files, and your log files, and it'll show you how fast or how slow those files are with latency to the disk. So as you can see here, the highlighted columns, we have our write latency, which is extremely high. So for a typical database file, you want your write and read latency to be under 20 milliseconds of latency on average. Right here, we're looking at about 1,429 milliseconds latency, and you can see the average between the two is about 710. So anything here over 20 to me is considered high. And for TempDB, it should be 10 milliseconds or faster, because it needs to be very fast because it's used in queries, so it's in and out constantly. So you need to have 10 milliseconds or less for an optimum performing system. So if these numbers are any higher than that, you have most likely some severe I/O latency between your server and your SAN. And there's a number of issues that can cause that. So we're going to look at that. So one way to easily measure the throughput is to use a few tools out there. One of the tools is called Crystal Disk Mark. Some of you may have heard that already. And so what we're going to do here is I'm going to run through a scenario that I recently encountered. And we're going to look at the initial server results. So I always like to take a before and after, and obviously in between if we're starting to tune, so that we can see kind of where we're headed. So the initial results here, you can see the throughput for sequential. This is sequential 1 in the queue, 8 bytes. It's about 326 megs throughput with 250. Now to me, that's pretty slow. So we have sequential 1 8 megabyte thread with one process, sequential 1 megabyte, one thread with one process, and then we have random 4K block byte size and with 32 processes in one thread, and then a random 4K one with one thread. So you can see definitely some performance issues here, because for a production database system, you probably shouldn't be transferring this slow. Now let me show you this. This is another example. This is my laptop. So my laptop, I actually ran Crystal Disk Mark just to show for comparison. And look at how much faster my laptop is. I can transfer for reading around 3,335 megabytes per second. And I can write almost at 2,000 megabytes per second. And that's pretty fast. So that's sequential 1 megabyte 8 threads, 1 megabyte 1 thread. And again, here we have 4K at 32 processors and 16 threads. So even there, we're getting over 1,000 megabytes per second, and writing is at 600. So you can see the difference there. So let's look at the comparison from this server that we first tested and my laptop. Now, I don't know about you, but I would think that my laptop probably shouldn't be faster than my production server, especially if you're running a multi-terabyte database and you have thousands of transactions a minute or even a second with a multi-terabyte database. That's pretty slow. So we did some upgrades, and after we did those upgrades, I want to show you what the server looked like then. So after that, the server looked a whole lot better. So we're now at 2,700 read and 1,500 write. Well, here I'm going to show you a comparison of before and after for that server. So this is what we are able to gain in the performance tuning that we are going to talk about here in a minute. So we went from 326 megs a second for read and 250 for write to around 2,700 for read and 1,500 for write. All right, there's another way you can test speed if you want to do some more in-depth specific block size testing for both read and write, and that's called disk speed. It used to be SQL IO, for those of you who've been around for a while, and it's a Microsoft product that you can run a command line and calculate results of the data as you're testing it on your disks. And you can do a number of different things with this. So I have a series of tests that I like to run and use, and I run them all typically on drives that I have problems with to do a before and after as well. So I'm going to show you kind of example of the output. Here's what it looks like at the output. So it does a test here, and it does, it's showing how many IOs it's performing. And in the interval, it did essentially 10 samples. The megabytes per second here were 10.92. IOs per second were 174, and then average latency was 182. So here you can see the totals or averages of all this for this particular test. So after we did our performance result or performance improvements, we tested again. Same test. In this case, we just added another drive with some of our performance improvements. And this is the new throughput we got. So our total throughput in our test was 1823. Our IOs per second are around, I guess this is a total 29,000. And our average latency was 10 milliseconds. So those two screens previously were on reads. Now we'll show you writes. So again, you can specify your test to do either reads or writes or a mixture, whichever you'd like. The reason why I like to do separate is because I like to go through the cache to make sure that it's not using the cache on the SAN to do a test of the actual disk. So here's what it looked like before. And you can see here that our total is about 86 megabytes per second. IOs are only about 1,300, and our latency is 231. After our performance improvements, we did a test again. And you could see that our megabytes per second was about 337, and our IOs were about 5,400. Now there, the latency still is what I would like it to be, but there's some more things we can do there to help fix that. So here's a comparison of before and after. And you can see there's a definite improvement in IOs. We go from 500,000 to over 8 million. Here we go, 400,000 to over 1.6 million. Again, 700,000 to 8.5, 300 to 1.3. This is a 64K random, read random, a write random. This is a read sequential. This is a write sequential. These are all 64K tests. Okay, so you can see the improvement there of those tests before and after we've done performance improvements. So here we've also done 8K, so you can see the 8K tests. Now I do these 8K tests on logs, on the log drives. So again, you can see the tremendous improvement here. We go from 684,000 IOs to over 50 million for random read. Here's random 8K writes. You go from 500 to 3 million. Read sequential, you go from 1 to about 49 million. And then write sequential goes from 800,000 to 3 million. So tremendous improvement there. All right, so one of the things you need to do is verify your network setup, right? Do you have multipaths set up from your SAN to your host or from your SAN to your physical server? So what multipath means is that essentially there are two network connections of high speed or more between your SAN and your switch, and then your host or your server. So typically in your server, you'll have 2 to 4 NICs in your server with ports that are anywhere from 1 gig to 100 gig in connection, which will allow you to connect to your SAN. Make sure you have multipath set up. If you don't, you're going to have latency. You're not going to have as much throughput as you can. Your SAN can support a whole lot of traffic, and if your server or your host is not accepting that or able to support that, that's something that needs to be fixed in order for you to get the maximum benefit from your server and from your SAN. What is your connection speed from your server host to your SAN? How many of you know currently who are listening, how many of you know what's your current SAN connection speed? You can just post it there in chat. If you want, tell me like 1 gig, 8 gig, 10 gig, 25, 40, 100. Go ahead and post it there if you know. If you don't know, there's your homework for Monday to go find out what you have. So currently, or I should say, in this one client that I was working at most recently with, they only had one 10 gig connection between their host and their storage device, their SAN. And they had a number of different servers connected to it, and they were, for the most part, only using that one pipe, that one path between their host, their VM host server, and their SAN. So they had 20, 30, 40 servers on that host. All of those were using one 10 gig pipe. So I'm not seeing anybody post in here. Did everybody fall asleep? Does anybody? So, okay. So one person said they don't know. Does no one else know? Just like let me know if you don't know. That's fine too. Okay. We got a developer saying that he doesn't know he's a dev. That's a good question. Go ask your DBA. Say, hey, what kind of pipe do we have between our host servers and our SAN in production? What kind of throughput do we have? It's a good question to ask. You ask that question, they'll be like, they might actually know something, which you might if you stick around for the rest of the session now. All these questions are good for your devs. For you devs out there, ask these of your DBA. He'll be impressed. All right, so do you have a 1 gig connection? Do you have an 8 gig connection? Do you have a 10, 25, 40, 100? So just so you know, if you have 1 connection, that's your bandwidth. If you have more, obviously you have more throughput. So you could have 2 connections, you could have 4 connections, you could have 8 connections. Again, connections times bandwidth equals more throughput. All right, cool, we have a student. Thanks for coming out. It's a great place to learn for free. Yes, so multiple NICs, essentially, you would connect multiple cables to multiple NICs on the back of your host. Those would individually go to a switch, and from that switch, those would also then have individual connections back to the SAN. Yes, if your DBA and infrastructure is a separate entity, definitely get with the infrastructure team. Ask them, say, hey, I'm interested in knowing how the server and hosts are set up to the SAN. Can you give me a little information on our connections to the host in the SAN and the switch that we're using? Another thing that could be a bottleneck is that your host may have, let's say, 100, or 10 gigabyte card. Your switch may be only 1 gig. So if you're going from a 10 to a 1, and then your SAN could say support a 40 or 100 or 25, your slowest point in that piece is your switch. You're limiting yourself in that. So make sure that you definitely have the same wide open bandwidth throughout all of your hardware there, because it matters. Oh my. So someone, Jason says here that his system and infrastructure guys hate us devs asking questions. Well, if you have a performance problem, these are the questions that I would ask, right? And if they're unwilling to answer, then, maybe you need to go above them or go to your manager and have your manager ask them. Because if there are definitely performance bottlenecks in production, these are the type of questions that would shed some light on if it's an infrastructure problem from that standpoint. And obviously testing the throughput would give you a very good idea as to what exactly happened. Now I can give you another instance. I was working for a company a few years back, and we had infrastructure and we had SAN team, and I came in as a production DBA for this particular company, and the SAN and infrastructure guys kept on claiming that, hey, there's no problem. Look, the latency is great on the SAN and on the host. I'm like, okay, but when are you testing that? Are you testing it at idle? Are you testing it at the hardware device? Are you testing it actually in the VM itself? So it took a little while to get through to them. And we had to kind of take baby steps. But one of the biggest things we were able to do, and I would recommend this for anybody, is to get your teams on the phone in a call with your management and get the teams on the line and say, hey, guys, can you open up your monitoring tools? I'm going to run a query now and show you the latency that I'm seeing. One of the biggest things to help track this down is obviously monitoring tools. Monitoring tools and then the ability to do queries like in the DMVs. If you don't have access to the DMVs, monitoring tools can help. But if you're on a call with them, tell them to open up their monitoring tools and monitor. You run a query. I did this after several months going back and forth and saying, hey, we have a problem. Here's the problem. No, it's fine. Right? So I ran a query while they were watching. And they saw at that point, as soon as I started that query, the latency that I was talking about, the performance issues that I was talking about with one query. So actually having them on a call with their monitoring tools while I tested enabled us to then allow them to see, hey, there is an issue, and then they went and fixed it. So I would highly recommend that if they're not willing to, just take recommendations or answer questions, get online and show them what's actually happening. Makes a difference. All right, so for those DBAs and SAN administrators out there, you want to verify your network setup, right? You want to make sure that your jumbo frames are enabled. So a lot of times the infrastructure side of the network is on its own separate network, right? And a lot of times they can be set, that infrastructure network can be set to jumbo frames. It should be, right? Because what happens is instead of sending a typical 1,500 kilobyte packet through, you can now send 9,000 byte packet through. So one packet is, almost 5, 6, 7 times the size if you use jumbo frames. So is jumbo and frames enabled for either A, your SAN network, which hopefully your SAN network is separate than your main network, but if not, definitely your infrastructure network. See if it's set up to jumbo frames. There's an easy way to test that. The way you test that is you can perform a ping with the -L, which specifies your packet size, right? So here you can see I started testing with an 8192 packet size shy of 9,000. And you can see it times out. So to me, that tells me that, hey, jumbo frames is not enabled in this network from this server to this device. Now, this device here was one of the SAN ports, right? One of the SAN connection ports. But if I test it here with 1470, which is under the 1500 byte size, it went through fine. So that tells me that jumbo frames is not enabled. So that's an easy way to test that. You can test that yourself on your servers. Drive configuration. So this is important when dealing with throughput and reading and writing for SQL Server. Are your data drives formatted in 64K blocks, right? So the way you can tell this is run this little utility, fsutil, fsinfo, ntfsinfo, C. In this case, I did it on C to show you that it's formatted in 4K, okay? You don't want that for your data drives. You don't want your MDF and your NDF files on drives that are formatted in 4K. You can then, here's a copy of the command, you can run this. I ran this next on a D drive to show you, and you can see here that the bytes per cluster are 65,536. Now that's 64K. So this drive here is formatted correctly for data. That's what you want to see. If it's not, you need to get all that data off of there, format it, put all the data back on, or you need to stand up a new drive and then move your data over and you can delete the old drive. Another thing you need to make sure of is, are your log drives formatted in 8K blocks? The reason why I'm asking this is because this is Microsoft's best practice recommendation for SQL Server, that your data file is on 64K and your log is on 8K. So again, we use the same command. We run it on the log drive. And we can see here that the bytes per cluster is 8192, which is 8K. And that's what the log drive should be formatted as. All right, for those of you who are using older SQL Server, older Windows Server and older SQL Server, you need to make sure that your disk offset is correct. Now this really applies to anything from prior to 2012, so 2008 and 2005 and 2007, which I hope none of you are using still. We have a question here. Why should the log drives be at 8K, not 64? Because that's what Microsoft has said is best practice for that, because the log writes to the disk in 8K pages in that instance, and that is where you're going to get the best performance for your log files. So for your best performance, it's best to put log files on a drive that are formatted in 8K, because you're going to get your fastest read and write for log files off of that. You don't have to listen to everything Microsoft says, but this is what the community has also tested with, based on what Microsoft has said. And definitely, in my experience and others in the community, has found out that this is definitely the fastest way. So, from experience, that's why I would recommend it. All right, so disk offset. So disk offset, essentially, it's to explain it simply is where all of the data starts on the physical disk. Now, this doesn't ring true going forward, say from 2012 on, because Windows automatically fixed this and the SANs automatically fixed this. But previous to that, older versions, you need to make sure your offset for your data drives all start at the same point. So typically you would start at the 1 megabyte offset. So you wouldn't start your formatting, anything less than 1 megabyte into your disk, so that when you formatted, all of your starting points were at 1 meg and going further in the disk. And this has been tested substantially, and you'll get a 20 to 30% performance enhancement just fixing offset. So if you have an old server and you're using either local disks or SanDisk, make sure that your offset starts all at the same for all of your drives. So if you want to look at documentation that Microsoft has, here are partition alignment best practices, or disk partition alignment best practices, and disk performance will be slower when you have multiple disks unless you fix those. Okay, so there's 2 links where you can grab and go look at. All right, so for older OSs, your drive alignment is correct. Consult your SAN for best practices. So sometimes your SAN may have a different alignment than, say, the 1 megabyte starting point. So obviously check that as well in case that needs to be a different starting point there. The way you can check this out yourself is by running this WMIC partition command, and you can get some information here. So you can get the starting offset. So if you look here, you can see how the starting offset here for all of these disks is the same. Now this is managed by Windows, and these are all of the SAN drives that you see here. Okay, so all of the ones that start the same are the SAN drives, and then the OS drive you can see here that started at 1 meg, right? And these are some other specialty drives, so you can just ignore those. But you can see here, all of these and all of these are the SAN drives, and they are all have the same starting offset, and that's what you want to see. So if you have local drives, you want to see them at least 1 meg. If you have SAN drives, they should all start the same. Again, your SAN should manage that, okay? But just make sure that they're all the same so that you have the best performance. All right, so we want to talk about what your data is. Know your data, because knowing your data is key. Okay, we have a question. So by default, backup drive should be 64K as well. Yes, 64K for backup drives is Optimum for backup drives. So definitely, again, same thing as your data, because you're writing there. Definitely have your backup drive 64K. Good question. All right, back to the data. Is your database doing CRUD operations, OLTP? Is your database doing an insert only, like logging? Sometimes you have one database for OLTP, and sometimes you have database for logging. So depending on that, you may do different things as far as how you partition or how you set up your system. Does it make sense to partition? So like for logging, I would say definitely consider partitioning, because you're just dumping rows and rows and rows in there, and you're probably not going to use them extensively, probably past the current, prior to the current month, right? So partitioning those in a monthly interval is probably the best for index maintenance and for performance. Are you using a data warehouse? You could partition your data warehouse, or you could use things like cluster column store indexing to help with your performance there. How do you query your data? You need to know this, right? If you're partitioning, what column makes sense? Do you have a primary key ID? Do you have a date time? Sometimes it's easier to just partition on date. That way you can just query the most recent partition. If you're doing primary key, again, you can query and segregate all of your data files based on how many rows you have in the table. Do you just use a date? Do you use a bit, like an active or unfulfilled? Do you use an int? So you could have a table where you're just looking at statuses. You could partition it by status, where you'd only look at things in, like, say, unprocessed status versus processed. Are you using clustered keys in your queries? Are your indexes supporting your queries? So if you're using partitioning, you definitely want to make sure that you're using those clustered columns in every query to make sure that it's going to the correct cluster or the correct partition. As far as data retention, do you really need 2.5 billion records in that table? Can you archive them? Can you compress them? Determine your retention periods. Work with your business, work with your applications, work with your legal team. Find out, do you need to keep this data a year? If it's log data, do you need to keep it more than 30 days? If it's financial data, you probably need to keep it 7 years. Do you need to keep it on hot storage, or can you partition it and put some of that on cold storage, slower storage? Determine your typical search range. Like, do you search within the past month? Do you search in this most recent quarter or this year? How far back do you typically search in your queries? Anything that isn't in that typical range, you could probably partition it separately or archive it. Based on the number of records also per period, it'll determine your partitioning structure. So when you're looking at trying to figure out how to do this, look at both your date range, how many records are, say, like in this last month or in a given month for a year, and also look at, okay, if you're going to partition by date, that means you're going to have 100 million or 30 million records in one partition. If that doesn't seem feasible, right, you probably don't want to partition for anything less than 100 million. So should you do an integer range for your partitioning at that standpoint? So between 0 and 100 million, then 100 million and 200 million would be your next partition. So look at your data, understand your data. So how many of you use Unicode characters in your database? I'd like to see a show of hands or comment in the chat. Let me know how many of you use Unicode characters. All right. Eli, what kind of Unicode characters do you use in your database? Are you using a specific language, like a complex character set, or is it just the data types? Okay, so using regular English inside of Unicode characters. Okay, right, exactly. All right, so what are Unicode characters or Unicode character data types? You are correct. It is definitely a bad idea, and we're going to talk about that right now. So nchar, nvarchar, and ntext. Does anybody know what the N stands for? Without Googling it, does anybody know what it stands for? I wish I had music to play here. All right, so I see no one commenting. No, it essentially supports extended character set. There we go. Hugo has it. Close. It actually stands for national language. National character set is what he said, so close enough. Yeah, so it stands for national language. So it allows you to essentially store complex characters in those columns. So certain languages, like Chinese and Japanese, they have their hieroglyphics that they can actually store in those, and those will actually fit inside of these columns. Now, for regular text, English, Spanish, you don't need those, and it's overkill, and we're going to show you how much overkill. First off, actually, before we get to that, let's talk about text, ntext, and image. How many of you use these columns in your database? Anybody have a text, ntext, or image? So I know a couple of you were using 2005, 2008. Do you use these columns? I know 2005, that's probably your big text field, so I'm guessing you're definitely using that. But anybody newer than that shouldn't. So I hope you're not using them because they're deprecated, right? You need to move those data, move that data to new varchar max, var binary columns. So your image would go to var binary max. Your text and in-text should go to varchar max unless you're using Unicode characters. Then you could use nvarchar max, or you could use a varchar max if you're in 2019, and you could use a UTF-8 collation and actually store it in a varchar column. But that's another topic. All right, so just changing the data type won't help with performance or space savings, just so you know. So text and in-text fields actually reserved bytes specifically for that column. So you're familiar, I'm sure, with how varchar essentially is a variable character column, right? That's what it means. So if you say, hey, the max I can put in this is 100, and you put in 50, it's only going to use essentially 50 bytes. Now, if you made it a char 100, it's going to still use all 100 of those bytes because it's reserved that space. Well, text and in-text, that's the way that works, right? So that space is always reserved for the data when you put it in there. It bloats. It doesn't come down to the data size that you use. Also, if you just say alter the column and change your data type, it's not going to really change the underlying data type in the database, and or say the performance or space savings. You actually have to add a new column and then move that data over and then delete the old column. All right, so let's talk about the difference, the size difference between nvarchar and varchar. I'm guessing some of you may already know this, but anyone know the size difference between the two? So we have one person that has said double. And you are correct. nvarchar uses 2 bytes more or more per character. So by default, out of the gate, if you have a column and it's a varchar 50, it uses 50. If you have an nvarchar 50, it's using 100. Varchar uses 1 byte per character. So let's look at the size difference and how much of an impact this has. All right, so here we have a test text here, and we have some testing of that text times 600 million. And we're going to show you here in this test size that this column here is a nvarchar and this is a varchar. And you can see that here it's 19,000 megs versus 9,000. 18 gigs versus 9 gigs on 600 million record table. That's a big difference. I mean, if you had a database backup and you just change your data type from nvarchar to varchar, that would literally cut your database backup in half, right? If that's what you were backing up. So let's test this on a larger scale. We'll go to a field that is 8,000, varchar 8,000, or nvarchar 8,000 versus a varchar, 4,000. These are nvarchar 4,000 or a varchar 4,000. Text filled out completely, right? So you have 4,000 characters in both of the fields, both of the columns, so 600 million records. Your nvarchar column size is 4 terabytes. Your varchar is only 2. Half the size. So the more records you have, if you have a notes column and it's filled to just about capacity and it's nvarchar, you're wasting twice as much space as you could, and you could cut that in half by going to varchar. So unless you need Unicode characters, you don't need it. Well, all right, great question. But then you get the argument. So Eli asks, you get the argument that space is cheap. How do you combat that? So let me tell you how. You tell them that space is time and time is money. If I had to transfer 8,000 bytes instead of 4,000 bytes every single time I do a query, that's more time that query has to take to come back. Okay. Next, every time I do a backup, I'm doubling the amount of space that I need for that backup, which means I'm doubling the space that I'm transferring over the wire for that could be used for other applications. So essentially, I've out of the gate bloated all of my network traffic, all of my data backup space, all of my database size space times 2 out of the gate for no reason. Cut that in half. Now your database is going to be faster, your backups are going to be faster, your application is going to be faster. So you get a tremendous amount of performance improvements, space-saving improvements, time improvements by just making that data type correct or smaller. If you use database compression, it'll compress it. But again, still, are you compressing 4,000 bytes? Or are you compressing 8,000 bytes? Right? You still have to compress and expand that. You're still transferring that data to compress and expand that. So again, if I were to back up an 8,000 varchar and varchar 4,000, which was 8,000 bytes, versus compressing a varchar 4,000 with 4,000 bytes, it's going to be a different size. So again, it all adds up. Okay, even if you compress. And again, once that puts on disks, you're still there. You're still going to have that space. So it matters. All right, date time and date time 2 difference. So date time is 8 bytes. Date time 2 can go from 0 to 7, but with a higher accuracy. So previously, date time had 3 increments of accuracy, and now with date time 2, you have 100 nanoseconds accuracy with 100 nanoseconds. I'm going to start going through this a little faster because I'm almost out of time. But if you compare or change your date time, if you don't need that much precision, change your date time columns. Okay, I'll give you some examples. If we just did date time with seconds, you would go down to 6 bytes. Okay, if you can, and then normally you would have a date time column which would have your full with your precision, and that's not needed unless you need that precision. So you save 2 bytes per row, and in a database of say 600 million records, you could cut off about a gig by going down to that size. And you can see here 4,500 megabytes to 3,400 megabytes by changing date time to date time 2. So I'm going to give you an example of one table that we looked at. We took a date time, created a date time table, went from 8 bytes down to 6. We did modified date time, again, 8 bytes to 6 because we only needed the seconds. Order date, we went from a 8 to down to a 3 because we went from a date time column down to an actual date column, which is now available. So we cut off the time and the seconds. Fulfill date, we went from, again, 8 bytes down to 3 because we only needed a date. Return date, again, we took our nvarchar column, went from 8,000 bytes per row per column down to 4,000. And we did this on a table with 100 million rows or 600 million rows. So with our 5 date columns, we went from 20 gigs for those down to 10 if we went 6, or if we went down to 3, we went to 5 gigs. So we cut that by essentially 15 gigs. We saved 2 terabytes by just converting that one column. Now, think of this. If we did this per table, and you have multiple tables with hundreds of millions of rows in, or billions of rows in, how much more is this going to save you? So we went from 20 to 5 and 4 to 2 on one table. We saved on space for that table. We saved on backup. We saved on restore time and bytes transferred. Another thing you need in order to get to this point is you need to turn on IFI, Instant File Initialization. This allows you to grow your disks and zero out before you actually write to the hard drive. So you can check to see if it's enabled by looking at your server. You can also go and turn this on in your local security policy. And this is how you can also set it by adding your service account to your administrator group if you want to do it that way.
Jeff, if you could wrap up, I think we're actually a little over time now.
Okay. All right. So the next part of the session, and I'm sorry to get to it, is creating the actual file groups. But those key points that I talked to you about with the fixing your data is going to show us your biggest improvement. If you have any questions, give you my last slide here. You can reach out to me and email me, and I'll be glad to answer any of your questions. I'll put my slides online, and you can go ahead and look at them.
Okay. Do we have any quick questions for Jeff? I know people have been asking him throughout. But... All right, and Jeff, if you wouldn't mind putting your contact information in the Discord channel as well, that would be
sure
useful for folks looking for it later. Thank you very much. A lot of great information here, and a lot of good questions from the folks. And it looks like you answered a lot of good questions for folks. So we do have a short break, especially for those who are looking at changing rooms. Remember to go ahead and do the speaker survey. I posted that a little earlier, and if you're looking for it later, it's in the Discord channel. And we also, don't forget, this afternoon we're going to be meeting up in McFly for a social event. And thank you, Jeff. I appreciate your talk.
Thanks for having me, and thanks for all the great questions. I'll stick around for a little bit if anybody has any more questions. I'm also in Discord too, if anybody's on there and wants to hit me up there.